So let's consider a rod. Let's consider a rod of length L, okay, which is having a mass M. Okay. So what are the natural forces? Of course, there will be gravity acting. So that is mg. I need to find elongation. So due to its own weight, the gravity is acting. The rod will extend towards downwards. So what will be the extension, change of length in this? So this is what I am interested to find. Okay. So to that, let's take a small element here. Let's take a small dx element. So this part, and I will be interested in calculating tension. So what will be the tension acting at this point? So just observe the points A and B. Okay. So tension at A would be just naturally balancing the below weight. So to calculate this below weight, the shaded part. So how do we get? So we need mass of this below weight. So mass of this of rod or the remaining rod, how can we calculate? So m L minus x by L. So this will give the mass of this rod. Yeah. So tension at this point will balance this mass. So T should be equal to the mass times the gravitation. So that we get tension. And in this small element dx, so we have same tension applied. Okay, what happens? See, I have considered the small dx amount. So let's I will just assume that tension T is acting above and the same tension T is acting below. Okay. So now both tensions are applying on upward and downwards. So there will be an extension of dl. Let's consider there is an extension of length dl. Okay. So now I will define a strain for this and stress for this. So strain, I know it is defined as change in length divided by original length. So what is the change in length? dl. So what is the initial original length for this element? That is dx. So this will give strain for me. And stress is defined by restoring force divided by area. So what is the restoring force here acting? So that is tension T, let's say, and divided by cross section area. Let's see the cross section area of this element. So that will give the stress. Okay. So now I'll put it in terms of Young's modulus. So we have this Young's modulus y, that is equals to stress by strain. So stress, what I can write from these equations, two equations, T by A as well as dl by dx. Okay. So once we get this formula, so I can just find out the equation for dl. So what is the dl here? dl is the small change in the length of this small element. Okay. Now similarly, I need to calculate the larger elongation in this rod, that is delta dl. So what can I do? I can just integrate this equation. I can just integrate this equation from 0 to L. So this is x is a variable, so x is varying from 0 to L. So that will give me the total length, change in the length. So integrating this one, so dd cancels out. Let's say there is a small changes happen, so that will give rise to delta L. Okay. On the right hand side, so these are constant m, L and A and Young's modulus. So take it outside. So integration of L minus x with the dx will give me on the other side. Let's say this is the integration value, L square minus L square by 2. Okay. So putting the equation in this equation, we get delta L is equals to mg by 2ay. So where A is m is the mass of the rod we have taken, and A is the cross section of the rod, and y is the Young's modulus. Okay. Young's modulus. So this will give the change elongation in the rod due to its own weight. Okay.